Hey everyone, welcome back. So in this lecture, we're going to get a little bit better into the nitty-gritty about statistical significance and what we do with those p-values when we get them in our output, right? Those p-values are going to be really important for us moving forward because it's how we're going to be able to determine whether or not we think we actually have evidence for our hypotheses with this set of inferential statistics we're doing. There's a lot of kind of back and forth about the best way to teach p-values. I'm going to teach you the closest way I know in terms of the way the statistics community wants p-values to be taught. It is a little bit complicated, I will preface that, but I'm going to give you the best way to kind of operationalize the language in your written assignments and for your final project. But this is a moment too where if you're struggling with this stuff, please feel free to reach out. It is a little bit difficult. So I just want to kind of start the video with that and just try to empower you guys a little bit too to reach out when you feel like you're struggling. The code should be pretty easy to implement, right? It's the same t-test code, but we're just kind of trying to understand how we're going to wrestle in words and make these sort of decisions on whether or not we can reject our null hypothesis, basically. All right. Let's start with the t-test that we were working with last time. So we had this t-test function, and in that t-test function, we were selecting out two variables, right? Our dependent variable or our ultimate effect was the midterm data set, right? Or the midterm variable selected out of the student data set with the $sign. And then our cause was major, right? So student data, $sign major selects out the major variable from the student data set. And we're doing a t-test, right, which compares two means, right? It's comparing the means of majors and non-majors. Remember, we got this beautiful output, which showed the mean of each group. So the mean of non-majors on their midterm score was 48.66. The mean of majors for their midterm score was 62.44. Remember, we also got our test statistics, test statistic, which was negative 3.109. And our degrees of freedom were 21.027, which allowed us to get a critical value that we could then compare to this normal distribution and decide whether or not we thought we had a statistically distinct result. But the kind of shorthand way to do that in R is just to look at the p-value, right? So this p-value is reported on the same line as your test statistic and your degrees of freedom, right? So the p-value in this case is 0.05306. All right, so let's talk about a bit about what that means. So a p-value, the definition of a p-value is under the probability under the assumption of no effect or no difference. So the probability under the assumption that the null hypothesis is true of obtaining a result equal to or more extreme than what is actually observed. It's going to come as a value between 0 and 1. And then our threshold for statistical significance is going to be 0.05. So if that value, that p-value is less than 0.05, then we can say that this probability is very low, i.e. the null is unlikely to be the truth, so we can reject it. So less than 0.05, we can reject the null. If it's above 0.05, we accept the null. Okay, so all of this conversation about p-values is kind of couched under this assumption that the null hypothesis is true, and we're trying to disprove the null with our working hypothesis, right? So we're trying to understand how extreme or rare our test statistic would be if that null was true, right? Which means that we aren't really, we have no basis for understanding or no basis for our effect being true, right? In that case, if the null is actually what's really happening in reality. So think about us trying to figure out what's happening in reality, what's happening in the data. And the p-value is trying to say the unlikelihood of us getting our test statistic given the null being true, which is kind of a hard concept to wrap your head around, right? But essentially what we're trying to say that we want to get a low probability of our effect happening if that null was true. Because if we have a high probability of that effect happening with the null being true, we likely don't have any evidence. So let's talk about how to operationalize this a little bit more clearly. So we can interpret these as percents. So the p-value of 0.05 is a 5% chance that we would get this result if the null were true, right? If there was actually no effect. So we can reject the null in this case in favor of our hypothesis. But if we get a p-value of 50%, there's a 50% chance that we would get this result if the null were true, right? Which we don't want the null to be true if we're looking for evidence. So we failed to reject the null in favor of our hypothesis. So you can think about it in terms of the percent chance we would get this test statistic if the null were true. There's also some language in the literature about as extreme or more extreme in this test statistic, but I want you guys to think about this kind of percent chance that we would get this result if the null were true. And you can obviously just report the p-value itself, but there are going to be occasional times I'll ask you to take that p-value into a percent and interpret it that way. But I think this is a bit more intuitive, right? So if we have a p-value of 0.05 or less, right, anything less than that we like, that's a 5% chance that we would get this result if the null were true. So it's very unlikely that we'd get that result if the null were actually the case. So it's likely the case that our working hypothesis may actually be correct. Okay, so sometimes we have null findings is what we call that when our p-value is greater than 0.05, right? So the p-value of 0.5 is huge, right? And that's what we consider a null finding. It's like we didn't find any evidence for our working hypothesis, all right? This can be helpful in some cases, especially when that finding is counterintuitive in some way, when you really think that there should be evidence. So you might actually have some basis to say, well, this other thing is happening. This might actually be more interesting. So having insignificant findings is totally fine for the purposes of our course. I do want to just note, so like when you guys do your final paper and you're doing these sort of inferential statistics, it's okay to have no findings. You just need to interpret them as such. And also you can say interesting things like this is kind of counterintuitive. We would think that this would be the case. We don't see evidence here. Maybe this is actually what's happening, and you can interpret it, you know, and start thinking about other ways to get at your questions. So let's go back and look at our example cases. So in this case, we're looking at the relationship between midterm scores and major, and we had a p-value of 0.005306. 0.005306 is less than 0.05. So in this case, we can reject the null that there is no relationship between midterm score and major in favor of our hypothesis, our working hypothesis, which was that major is related to midterm score. And so we have a little bit of evidence here, which is great. Let's do one other example. So let's look at the relationship between major and political science homework scores. In this case, right, we can interpret the means of each group. So we have a mean in group 0 at 6.16. So mean in group 0 is non-major. Mean in group 1 at 7.689 is the major homework score. And we have a p-value in this case of 0.033. That means we can also reject the null hypothesis that there's no relationship between homework score and major in favor of the fact that maybe political science students do better on their assignments broadly in their political science courses than students that maybe are a little bit less invested in the course, right? So the p-value of 0.03 is less than 0.05, so we can reject the null. You can again turn this into a percent. So in this case, there's a 3% chance if you move that decimal point 2 places, there's a 3% chance that we would get a result like this if the null were true. It's a very small threshold, right? It's a small percent. It's a small probability. And so in which case we can have some confidence that our evidence in this case is pointing in favor of our null as opposed to the evidence is in favor of our working hypothesis rather than the null. So this is a kind of brief start on how to do statistical significance. I also want you guys to think about this in terms of the code you have and where to find the p-value. And this is going to be a little bit complicated. Again, I'm going to say that. So I want you guys to feel confident asking questions if you don't feel like you understand how to interpret p-values. But I do think interpreting them in terms of percents is a good way moving forward to start thinking about it.